Hi, in this video I'm going to show how to generate C++ code from a YOLO version 2 a convolutional neural network that is used to detect objects as shown in here, in which you get the category and the location of the object. And the generated C++ code is going to use the Intel math kernel library, MKL-DNN. And the purpose of generating C++ code is basically to deploy your model into an embedded system. So in this case, it would be the car. You compile the C++ code into object code that runs inside the car. But in this example, we are just going to compile the code into a MEX file so that we can run it within MATLAB. Okay, this is the example that I'm going to use, and it's going to be linked into a reference of this video. And also in the reference is going to be another video that talks in more detail about the YOLO version 2 neural network. So I'm going to focus only on code generation here. To start the script, go in here, and the first step is to load the YOLO version 2 network. The YOLO version 2 network is easier to use than the YOLO version 3, but YOLO version 3 is more effective. Okay, I'm gonna pause here because this takes some time. It finished, and we can see that it has 150 layers, and these are the inputs and the output names. Okay, so let's analyze it. It's gonna take some time to load, so I'm gonna pause. Okay, so you have here the network, and it's basically getting as input the image, a color image 224 by 224. And it's going to have the usual convolution, batch, ReLU combinations. They have some max pooling, and then once you go in here, there's not much pooling for some reason, and actually there's not much pooling the rest of the way. There's some branching to get old features mixed up with the new one, the latter ones, and this pattern is going to be repeated multiple times, and when you get to the end, you're going to have a different convolutions that are not going to get your I would expect to see the box coordinates in the last layer, and there a separate branch with a category, and that doesn't appear here because I think that's computed somewhere else. You get a 14 by 14 by 24 features. Okay, anyway, so the script that we're going to use to generate code is this one. It's basically a MEM script that takes the input, the image, and the output is going to be the same image, but with the boxes of the detected object inserted on top of it using this computer vision function, insert object annotation, and you also insert the labels in there. Okay, so for MATLAB execution, not code generation, you have to take out the labels from the cell string or packet into a cell string. Yeah. Okay, so the most important commands in here are going to be loading the network. We're going to use a persistent object for it because we only want to load it once, and no pun intended. Okay, so once you load it, you are going to use the detect method with the input image with the threshold, which is a parameter of this network, and this is going to give you the boxes and labels, and we did not show that in the network, so somewhere around here is converting that output that we saw into a corresponding box and labels. Okay, so that's the code that we're going to use for code generation. So these are the commands to generate code. We create a MEX configuration. If we wanted a library or other type of option or an executable, we put exa in there or lib in there instead of MEX. But we're getting a MEX automatically. So basically, by generating code using the codegen command, we're not only going to generate the C++ code, but also we're going to compile it and build it into a MEX that we can execute. Okay, so the target language is going to be C++, and we need a deep learning configuration to use the math kernel library of deep neural networks from Intel. So this is what is going to get us that. So we're going to pick the generate code in a moment. And okay, so the command here is you take the configuration, you take the name of the file for which you want to generate code, and the arguments could be a couple of things. It could be an actual value, which is what we're doing here. We're passing a tensor of base type unsigned integer 8 with all ones. We could pass a real image, but also we could use the color dot type of to pass the type itself. I found this a little bit more convenient. Okay, so I'm gonna make a little experiment in here. I'm gonna put the preserved dimensions in here. Okay, I'm gonna pull the command. I'll be back. Okay, I got the command. It's this one, preserve array dimensions. So this is not part of the example, but I would like to see if it is able to preserve dimensions for it. If it errors out for some reason, I'm gonna try it without this. Okay, so I finished generating code, so let's take a peek. The entry point is going to be the same name of the file, which is YOLO version 2 detection. So we should expect a CPP file like that, which is this one. We have the same name as the entry point, and you can see you have the inputs perfect. It worked. So we have the dimensions preserved. Instead of having a one-dimensional vector, we get the 3 dimensions in here. It is the order of dimensions was inverted because we are using column major and C++ is row major, so you have to invert the order. But if you put row major in here, you should get it into the same order. Okay, so here's the main method activations. It's gonna go into the YOLO version 2 network, and then you do some post processing, which you get the boxes and the labels, and that is fed into the insert object annotation, which is the computer vision function to insert the boxes into the output image. Okay, so that's your C++ code, and now notice that we also have a compiled MEX file in here, and that's the one that we're gonna use. So we're gonna execute these commands, but I'm gonna execute it from here because I want to debug through them. Okay. Okay, let's put a breakpoint and just hit F5. And now we get the file. We get the video file reader. It's gonna read the images one by one from the video, and this is gonna be used to basically display the images. Okay, so let's go inside. Let's take the first image. We have a size that is not expected by the network, so we have to resize the first 2 dimensions. The last one is a quarter, so we can leave as is. It's an unsigned integer 8, so no casting is needed. So here we invoke the MEX file. It has the same name, underscore MEX, and we pass the input image, and we're gonna get the output image and use this depth video player to just display the output image, and then keep going. So we basically get this image. So I'm gonna keep it running so that you can see the rest. Yeah, so we're running the MEX file, but yeah, as mentioned before, the generated C++ code is supposed to run in the embedded system when it's compiled with the proper frameworks. Okay, so you can see if the car is moving to the right and detecting various vehicles. Okay, so this is it. Thank you very much for watching.